Okay, now coming to the semiconductors. So these semiconductor memories, the next topic. So in this particular semiconductors, first of all, these are memories, and here I am calling registers. Registers are nothing but they are sequential circuit. Generally, they are used to store certain numbers. Okay, for example, if I want to store a big movie or a huge data, that is not possible in a simple registers which have some maximum 64 flip-flops, not more than that. They don't design more than registers which are having a capacity more than 64 flip-flops. Okay. Okay. So if you want to store a huge data, we have to go for memories. You can consider registers are very tiny memories, okay, or you can just ignore. There are some very small memories. But when it comes to particularly memories in general is nothing but it is an electronic storage unit which can store huge number of bits, and they are basically semiconductor devices. So semiconductor memories. So here you will be dealing with, okay, ROM, okay, ROM and RAMs. The main memories are the ROM as well as RAMs. What is ROM? ROM stands for read only memory. So every memory circuit has two functions mainly, there is reading and writing. If you want to store some data into the memory, or if you want to put some data into the memory, it is called as writing operation, and if you want to pull out the data from the memory, or if you want to retrieve the data from the memory, it is called as reading operation. So this particular memory circuit, it will do only reading, read only memory, and it is a non-volatile memory, and this ROM is not a sequential circuit, it is a pure combinational circuit. Previously I told combination means memoryless. Now I am calling ROM is a read only memory. I am calling this memory circuit. Why? Because this ROM is a unit, a memory unit, which is made up of decoders and encoders. So ROM can be considered as decoders followed by encoders. So decoder, encoders are combinational devices, so I will call ROM as combinational. Now if you are not satisfied, the basic building blocks of ROM are AND gates and OR gates. So if any digital circuit, if it is made up of the basic building blocks, logic gates, then it is called as combinational circuit. So ROM is combinational. No, if you are not satisfied, then in a ROM the present output depends only on the present inputs. That's why ROM is combinational. So generally in the interviews there are these kind of questions. Why ROM is combinational? This is the reason. You can simply call the basic building blocks of ROMs are AND gates and OR gates. That's why ROM is combinational. So ROM is a non-volatile, and it is an important memory device where you will be storing important programs, important important information. Any important information you want to store permanently, then they will use ROM circuits. A simple example I will tell you. For example, if there is a laptop. In the laptop, you are loading, first time you are loading operating system. Now this operating system, where it is stored? This operating system is stored in read only memories. Why? Because once if you switch off the system, the operating system is not getting erased, but the system is getting switched off, but still the operating system is present inside because it is present in a read only memory. So ROMs are basically memory devices which will retain the data permanently once if they are stored. And there are different types of ROMs. Okay, the discussion is lengthier, so I am just limiting this part here. Now coming to the RAMs. So random access memory, RAMs, and there are two types of RAMs. You can just see that SRAM and DRAM. S stands for static, or D stands for dynamic. So what is this RAM? Random access memory. Random access means the CPU, the central processing unit, is accessing, okay, the memory, and it is taking the same time for reading and writing. So it is a random access. Or I will tell a simple practical example where these RAMs are used. For example, there is a laptop, okay, laptop or desktop. In the desktop, when you switch on the system, on the desktop you will see all the icons and all those things. Now the question is where these icons and all those things are being stored. They are stored in the RAM, the random access memory. Once if you switch off the system, whatever is present on the screen, all the icons and all those things, the desktop, it will be erased. You will see a blank screen or the dark screen. Why? Because the RAM is being erased. So whatever you are seeing on the screen of a desktop, the contents are stored in the RAM. So whenever there is no power to RAM, the data will be erased. This is the best example what I told you just now. So RAMs are nothing but they are non-volatile memory devices. Once the power is turned off, then the RAM will be erased. But whereas a ROM, it is quite opposite to it. So RAMs are basically memory devices. They are pure sequential devices. They are not combinational, and they will store data permanently. And there are two types of RAMs, SRAM and DRAM. S stands for static. That means in these RAMs, the data will not change frequently. Static. Data does not alter. Dynamic. In these RAMs, the data might change. Why? Because the memory cells of DRAM are made up of capacitors basically. So here in the DRAMs, the memory is stored in a form of charge, and in the SRAM, the memory is stored in a form of bits. So whatever it is, okay, both are okay, they are RAM circuits, they are temporary storage devices, there are so many differences. Let's don't go into the details. Okay, that's a part of the classroom syllabus. Now next coming to data and one more thing is PLS. PLAs. What is this PLA? There are certain class of devices called as PLDs. Programmable logic devices. Programmable logic device, in short called as PLD. Programmable logic device. So these programmable devices are, ROM is a programmable device, PLA is a programmable device. Okay, I am writing certain devices. ROM is a programmable device. Okay, PLA is a programmable device. PAL is a programmable device. So what are these programmable? First time when you put the data into the device, previously I told that ROM is made up of AND gates and OR gates. If you just see the complete inside of that structure of the ROM, there will be two mesh of interconnections. The first mesh is called as AND matrix and the next mesh is called as OR matrix. If you program the AND matrix, it is called as programmable AND array. If you program the OR matrix, it is called as a programmable OR matrix. Now, in the ROM, in the read-only memory, since you are programming, these devices are called as programmable logic devices. So in the ROM, the AND matrix is programmable and the OR matrix is not programmable. So, AND matrix is fixed and OR matrix is programmable. Okay, I am just repeating. In the ROM circuit, the AND matrix is fixed, it is not programmed, whereas the OR matrix is programmable. Okay, that is a ROM. Now coming to PLA, programmable logic array. In the programmable logic array, both the AND matrix is programmable as well as the OR matrix is programmed. Both the matrices or the meshes are programmed, or we say logic gates are programmed, AND gates as well as OR gates. So PLA. Now coming to the PAL. In the PAL, AND matrix is programmable and the OR matrix is fixed. So some matrix or some logic gates are being programmed, so that's why they are called as programmable logic device. And remember, these three are pure combinational devices, they are not sequential. So PLA is basically a sequential device, is a combinational device, it is not a sequential. And basically this is a more flexible device. So we can, using these three circuits, that is ROM, PLA, PAL, we can implement Boolean expressions. Simplified Boolean expressions and varieties of Boolean expressions you can implement. Multiple Boolean expressions you can implement using this. That is one advantage of these PLAs. And the PLA is the most flexible device as compared to ROM as well as PAL.